All right, fourth period video number 258, etc., etc., etc. If you need another video or another problem, well, it's posted. You know where to find it. Number 2. The graph of a function g is shown on the right. If f is given by g of x, what is the value of f prime of 0? So I need to take the derivative of g of x. So this is definitely a blow pop situation, right? Work from the outside in, one step at a time. So the outermost function is that first g. So g prime, but leave the inside stuff alone, g of x. So I should label what this is, f prime. And then chain rule, let's go to the next function. So times g prime, leave the inside stuff alone. And then I guess you could go one more, because sometimes the inside stuff is an x. We just really want to overkill our chain rule here. The derivative of x is 1. So it didn't really matter on this one, but if that was a 2x or an x squared or something in there, then we'd have to chain rule that as well. Okay, so f prime of 0 means 0 is my input to the other side. So g prime at g of 0 times g prime of 0. Okay, so g of 0. So I go to my picture. G of 0 is 3. So I need g prime of 3. And I need g prime of 0. So g prime of 3, that's over here. Let's see, the slope of that line, right? Because derivative is slope, is prime, all of those mean the same thing. So the slope of g at 3 is, let's see, the change in y is -5, the change in x is 5. So the slope is -1. So g prime at 3 is -1. And g prime at 0, so that would be the slope of this line. Let's see, that looks steeper. 5 minus -1 over 1 minus -2. Yeah, that slope is 2. The slope of that line piece is 2, which means its derivative is 2. And then -1 times -1 times 2 is -2. Gosh, what a lengthy problem that started out seeming so simple. A simple graph, simple equation, but the chain rule and the composite function stuff kind of complicated that one. Number 5. Oh, lovely. You had 5 problems with number 5. One of these table problems, so I'll just need to be careful to make sure I'm looking at the right spot. 5a, if h is f of g, so this is another chain rule problem. So f prime, leave the inside stuff alone, times g prime, leave the inside stuff alone, and then the derivative of x is just 1. So h prime at 2 means f prime of g of 2 times g prime of 2. Again, these composite ones are tricky. I've got to write them out. I can't do all those steps in my head. Maybe I could do it, but that's just too much to keep up with. Okay, g of 2, so now I go to the table. G, the function g, when x is 2 is 5. So g of 2 is 5. Now I need f prime of 5. F prime, when x is 5, is pi. G prime when x is 2, G prime when x is 2 is the square root of 2. So pi root 2. Funny, weird answer, but there it is. Part B is almost the same thing. In fact, all of these are chain rule problems. Let's skip part B just in the interest of time. And part C, let's do part B. F of x. Chain rule, chain rule, chain rule, chain rule. So I'm going to be super careful here. Start with the outermost f. I've got to keep up with all of these. So that is f prime. But then leave all the inside stuff alone. The inside stuff is f of x. Alright, then I move to the next f prime. Now the inside of the green is just f of x. And then lastly, the last f prime, and the inside of that one is just x. So now this is just a record keeping thing. Look carefully. Alright, so I'm going to plug in 2 to all of these places. F of 2 is 5. F of 5 is 2. And f prime at 2 is e. Goodness. Although that was the worst one. F of 2 is 5. F prime of 5 is pi. And then the last one, f prime at 2. F prime at 2 is e. So e squared times pi. Or pi times e squared. A wacky problem. So there's 3 f's back to back to back. Question E. If h of x is f of g of x, so that's a chain rule thing, minus 2g of x, then h of 2, I wonder if that's supposed to be h prime of 2. Oh, it doesn't say h prime, it just says h of 2. So f of g of 2 minus 2g of 2. We get so locked in on doing derivatives, we might overlook that this one's not a derivative. G of 2 is 5. G of 2 is 5. And then f of 5 is 2. And 2 minus 10 is negative 8. So that one might have been trickier because it was easier. That's not even a calculus problem. That's a algebra 1 problem. 5, 6, 7, 8. I feel like you had one like this on the quiz, yes? Product rule with a picture. So product rule, again, don't just take the pieces. You've got to do product rule. F prime G plus G prime F, or the other way around, because it doesn't really matter. You're adding or multiplying, so there's lots of ways to combine those, or to write that combination of things. And then all of that at x equals 3. Okay, F prime at 3 means the slope of the graph at 3. The slope of f at 3 is negative 1. G of 3 is just 3. G prime of 3, so that's the slope of G. That slope is 2. And then f at 3 So the function at 3 is 4. So negative 3 plus 8 is 5. Again, so you had to know product rule, you had to know that derivative is slope, and then you had to be able to read a graph, read the slope off the graph, and read the function values off the graph. So a lot of things go into that problem. A little bit of calculus at the beginning, and then a whole lot of algebra. Maybe this one warrants the stamp. Calculus is easy, algebra is hard. 8, 9, 10, 11. Oh, f of 3, that's nice. That should be an easy one. What's f of 3? It's the function evaluated at 3. Well, the dot is at 2, because I just want f of 3 is 2. Oh, perfect, because the next one's 14, and that kind of illustrates the other. If I'm approaching 3 from the positive side of things, or from the right, so I'm a little more than 3, that means I'm trying to approach 3 kind of on this branch. Where am I headed? Infinity or DNE? Again, and you saw that test. It kind of depends on the question as to which answer we want. All right, so 14, 15, 16, number 17. Yeah, the hardest part for me is making sure I get every third problem correctly. Limit as x goes to infinity. Okay, if x goes to infinity, that's the shortcut rule. Top no, bottom O equal co. But if you don't like the shortcut rule, then it's not that long. Pick off the biggest term from the top and the biggest term from the bottom, and x to the fifth cancel, and it became, that was the equal co problem, so negative 6. If you like the shortcut, the top no, bottom O equal co thing, that's great, I like it too, but only for x going to infinity. People get so enamored with that shortcut, they start doing it for everything. Number 20. Oh, that's an easy one. Finally, that's just straightforward power rule stuff. 15x to the fourth minus 12x plus 1. So 20 is D. I like those. 23. Uh-oh, product rule for sure. So don't just do, answer A would be the derivative of the first times the derivative of the second, but that's not how we do the product rule. In fact, the product rule, it's almost got to be C or D, because that's the only one that looks like someone did the product rule. So first times derivative of the second plus second times derivative of the first. And I wrote that backwards of how I said it, just to put the x stuff in front. So let's see, which of these is paired up correctly? 8x to the 7th, the secant. Okay, that's on both of them. X to the 8th with secant tangent. Yes, because the derivative of secant is secant tangent. The derivative of tangent is secant squared, so that, yeah. D is if you don't know the derivative of secant. (26). Oh, we haven't had one of these yet. What do I mean by these? I don't think we've seen this today. Quotient rule. So, start at the bottom, now we're here, or low D high minus high D low, or we got to keep the GF first for things to work. Let's find the pieces first, I guess. F prime would be -2. G prime is +2. That's nice. Answer choice E is if you don't know the quotient rule and you just do the derivatives over each other. So that's not it. GF prime. GF prime. So negative 2 times 2x plus 3 minus FG prime. 2 times 4 minus 2x over the bottom squared. They all have the bottom squared, so I got to focus on the top here. Negative 4x minus 6 minus 8 plus 4x. The x's went away, and that leaves me with negative 14. Negative 14, so answer A. 28, 29. Tangent line. So I need a slope and a point. They give me the point. Let me pause it. But I do need a derivative. So point and derivative, because the derivative will tell me the slope. This is going to be a quotient rule problem. I'm tempted to try to quotient rule in place here, since the derivatives are easy. Let's go for it. So GF prime. So G is 3x minus 4. F prime is 4. Minus the other way around. F is 4x plus 2. And G prime is 3. That's about as dangerous as I like to live right there. I live a pretty crazy life, doing quotient rule without writing work down. Okay, I need to plug in 4. This is one where I could simplify first, or I could plug in 4 first. I think I'm going to plug in 4 first. So 3 times 4 is 12, minus 4 is 8. And then 4 times 4 is 16, plus 2 is 18, all over 8 squared. Oh, I wonder if I could have simplified some stuff. Oh well. 4 times 8 is 32, 18 times 3 is 54. So that's negative 18. Nope. Negative 22. This is why we like safe stop problems, because we could just stop. Over 64. I'm starting to look at my answer choices here. It's got to be negative. That will reduce to 11 over 30 seconds. 11 over 32 with the negative. So it's answer choice A. Quotient rule, but then a whole lot of algebra to go with it. Another table problem, and another table problem combined with the chain rule problem. So outside in, one layer at a time. So f prime of g of x. And I bet that's one of the answer choices, but it's not right, because next I need to chain that onto g prime of x. And again, if you really want to go all out, the derivative of x is 1. Okay, and we want to evaluate that at 9. So f prime at g of 9 times g prime of 9. G of 9 is 6. F prime at 6 is pi. Two things at once without writing them down. Just life on the edge today. G prime at 9, that's 2, so 2 pi. 35. That should look familiar. In fact, is that not identical to the one on the quiz? I think it is. Something really close to it. Definition of derivative: f of x plus h minus f of x all over h. Don't forget the limit as h approaches 0. So that would be... Wait, what's the difference between... Oh, it has x at the bottom. Good catch. I couldn't find the difference between those two. So, well, which one is it then? It's B. Yeah, h goes to 0. So B. $38. Ooh, that looks yuck. I'm guessing if I plug in 7 pi over 6, I get 0 over 0. Yeah, because that would be negative root 3 over 2. And I can't really work that as a limit problem. So instead, what I'm hoping is this is more of a derivative type problem. Right? That's the derivative at A. Because it looks like a slope kind of thing. The plus sign maybe throws us off, but that's a plus sign because it was minus a negative. And if we plugged in 7 pi over 6 to cosine, we'd get negative root 3 over 2. So I'm not going to work this as a limit problem. Instead, I'm going to recognize that f of x is cosine, and a is 7 pi over 6. So f of x is cosine. Let's take a derivative and then plug in 7 pi over 6. So this is a tricky one, not because the derivative is really that bad. Negative sign. And then plug in 7 pi over 6. So the sign of 7 pi over 6 would be negative 1/2. But negative 1/2 is a positive 1/2. That's a tricky one, because if you forget about what the definition of a derivative looks like, then you're stuck and you're trying to do all sorts of limit tricks, which none of them will work on that. You just have to know that that's a derivative. $41. Let f be the function given by absolute value x plus 3 and continuous, differentiable, minimums. Maybe I should just graph that. I feel like I know what that graph looks like. It's the v, the plus 3 moves it left 3. So, Shelby, does that qualify as a flashback question? Flashback to Algebra 2 or Algebra 1 maybe, I don't know. Left 3 with a v. So there's the picture. Now I think I can answer the questions. Is it continuous at negative 3? Is it continuous at 3? Negative 3, I mean? Yeah, like I can just keep drawing the line. That's true. Is it differentiable at negative 3? Why not? You're right, it's not. A sharp turn or a cusp. So that's not true. Again, a derivative is the slope of a tangent line. How in the world would you draw a tangent line at a sharp point like that? There's like no way to know where to put it. Statement 3, f has an absolute minimum. Yes, that is the bottom, so that's true.
Could you also say that a function is differentiable where the graph of its derivative is continuous?
A function is differentiable if the graph of its derivative is continuous. So if it's graph, if this is f prime, continuous, it might even have a sharp turn. But this means that f prime, there is a value for f prime everywhere. So yes, that would mean that f is differentiable because it's got a derivative everywhere. You know what? It doesn't even have to be continuous because if f prime is defined everywhere, if f has a derivative, then this would mean that graph, I think this would mean that graph has a cusp there. So I'm not sure what the graph would look like. But clearly it's got a derivative everywhere.
Does that mean the double derivative would not be direct differentiable?
This would not have a second derivative. Neither one of these would, right? Because there's a cusp and there's a, yeah. And a lot of times in calculus, because you need those things, the problem will say, given the twice differentiable function, blah, 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 and that way you know, okay, I'm not going to run into any of this weird stuff. 44, last one. If the function is defined by, piecewise, so I'm already worried about two things, like, do they connect, like they've got to be continuous, but also, is it differentiable? So like the one I drew here is yes continuous, but no undifferentiable. So it asks for f prime of -1, but it can't have a prime unless it's also continuous. So even though it didn't ask that, I've got to check f of -1 like into both pieces. I should phrase that differently. I need to check the limit from both sides. That's a better way to say that. So let's see, when x is less than 1, this would be the left limit. If I plug in -1, I get -3 plus 5 is 2. The other one would be the right limit. So coming from the right, that would be -1 plus 7 is 6. So if I did that right, this thing is not continuous at -1, so it can't have a derivative there. So it didn't really even matter what the derivatives were. If we had passed the continuity test, then we would take the derivative of both pieces. So that one would be 3, this one would be -2x, and then we would see if those matched. Those don't match either, so this is a definite non-existent derivative. Alright, if you're looking for other videos, other problems, you know where they're posted. You can find them elsewhere.